Brought to you by Thomas Allgeier and Frennis. This edition highlights key LinkedIn posts on electrification and battery technology in weeks 26 and 27. Frennis is a B2B market research company that supports automotive suppliers with building feature-by-feature competitive intelligence that shows exactly how their product stacks up against the competition. You can find more info in the description. So welcome to the deep dive, everyone. Today our mission is unpacking the top electrification and battery technology trends that we've been seeing across LinkedIn over the past couple of weeks.
Yeah, thanks for having me. It's a really interesting time right now because the industry is rapidly maturing.
Definitely.
We're shifting away from this mindset of just, putting hardware in the ground and focusing a lot more on smart utilization, grid integration, and heavy-duty logistics.
Right. Okay, let's unpack this because we're starting to see a really huge theme here, right? This move from just building out infrastructure to actual utilization discipline.
Exactly. It's the most visible part of the transition, public charging. And the industry is realizing that the sheer number of chargers matters a lot less than, whether they actually work when a driver pulls up.
Yeah, Fernando Favol had a great post about this. He mentioned how the industry used to measure progress by just counting installed boxes, But the real goal is a driver pulling up and charging without a second thought.
Right, because that gap between installed and actually works, that's exactly where trust is built or, totally lost.
Yeah, and Bradford Chris from ChargeMate had some fascinating insight into this.
He did. Yeah. He pointed out that when a session fails, the driver usually assumes it's a broken charger, right? Like the screen is dead or whatever.
For sure. That's always my first thought.
But he notes that the hardware and the payment systems are usually totally fine. The actual issue is vehicle compatibility.
Wait, really? Like they just can't talk to each other?
Yeah, exactly. He gave the example of older Tesla Model 3s. They actually need a physical service retrofit to use third-party fast chargers because the communication protocols just don't match up.
Wow, so it's a software handshake issue, not a broken plug.
Right.
Well, that actually brings up Chris Jackson's breakdown of why Tesla chargers are so much cheaper and more reliable.
Oh, yeah, that was a great analysis.
I mean, Jackson noted that Tesla owns the whole chain, right? The vehicle, the charger, the software. So they build chargers for around $40,000 a bay, while the industry average is like over $100,000.
It's a massive difference. And because they have millions of cars feeding them data, they can predict demand perfectly.
Yeah, which is just wild compared to what's happening with the EVI program. Yeah. Angela E. detailed this on LinkedIn, and it's pretty bleak.
It really is. I mean, $5 billion allocated, and 4 years in, they've only spent about $94 million.
Which is like 2%.
Yeah, 2%. And that's resulted in roughly 120 stations.
Oh, man. And Angela pointed out it wasn't a hardware failure, right? It was this massive coordination breakdown across agencies, utilities, landowners.
Exactly. The lack of discipline left companies like Tritium, EVBox, and LG totally exposed.
It's honestly like building a massive fleet of airplanes, but completely forgetting to build the air traffic control system.
That is a perfect way to look at it.
I mean, you can build a charger in an afternoon, but aligning a dozen stakeholders is the real bottleneck.
Right. And building on those coordination failures, we really have to look at the most critical stakeholder of all, which is the power grid.
Oh, absolutely. Chelsea Millington Latham brought this up. She said EV charging projects don't even start with chargers anymore. They start with grid capacity planning.
What's fascinating here is how urgent this has become. Casper H. Rasmussen posted about this, and grid limits are a now problem, not a 2029 problem.
Right. Didn't he mention countries actually freezing connections?
Yeah. Denmark and the Netherlands are literally freezing grid connections. And during a recent heat wave in Belgium, evening power prices got pushed past €1 per kilowatt hour.
Jeez, over €1. That's insane.
It is. Flexibility is literally the only way forward right now.
Well, speaking of flexibility, Christian J. Pena shared a brilliant real-world workaround for this.
Oh, the one at the Cosmopolitan?
Yeah, down in Miami Beach.
Yeah.
So they only had 208-volt service available at the building.
Which normally means you just can't do a fast charger.
Right. Normally you'd need this hugely expensive utility upgrade, but instead they used a step-up transformer and managed load control.
That's so smart.
Yeah. They managed to fit a DC fast charger within the building's existing limits without waiting on the utility.
It's exactly that kind of engineering we need. Because since grid capacity is tapped out, the grid needs the EVs just as much as the EVs need the grid.
Oh, so moving into vehicle-to-grid or V2G.
Yeah. Biswaneth Bose summarized the IEA Global EV Outlook, and V2G is finally entering commercial reality.
It's about time. Feels like we've been in pilot phases forever.
Right. But Europe is leading this, and hardware from companies like Mobility House and Costal is actually ready.
And Jennifer Granholm had some praise for GM's strategy here, too. She noted GM has already sold nearly 250,000 vehicles equipped with bidirectional charging.
250,000, that's a serious fleet.
Yeah, it's all about turning the battery in your garage into an asset, something that keeps the lights on and stabilizes the grid.
But, of course, it's not perfectly smooth yet. Manfred Priscilla gave a dose of reality by breaking down Helion Energy's V2G rollout in Switzerland.
Okay, what's the holdup there?
Well, it's a really bumpy road because you have 4 distinct software platforms that have to synchronize perfectly.
4? What are they?
The vehicle, the charger, the home energy management system, and the trading platform.
Oh, wow. So if one of those lags, the whole thing breaks.
Exactly. They have to balance the needs of the driver, the homeowner, and the grid operator all in real time.
And there's a huge behavioral hurdle on top of that. Gregor Eckhart mentioned that drivers often just don't bother plugging in if their battery is already full.
Which totally ruins the reliability of V2G. If the car isn't plugged in, the grid can't use it.
Right. So to fix this, Nissan and EaseLink are actually testing automated AC matrix charging.
Oh, I saw that. So the connection just happens automatically.
Yeah, without the driver doing anything, just park and it connects.
That solves the human element, definitely.
But wait, I have to ask.
Mm-hmm.
If we're constantly draining and filling these car batteries to support the grid, aren't we just going to destroy the battery's lifespan before the car's even paid off?
It's a great question, but the hard data says otherwise. Ashu Patel shared a report debunking the whole battery degradation myth.
Really? So they aren't dying early?
Not at all. Real-world data shows modern EV batteries are retaining 80 to 90% of their capacity even after 200,000 to 300,000 miles.
Wow. 200,000 miles is a lot. How are they doing that?
Better chemistry mostly, like LFP batteries, combined with really advanced thermal management.
That perfectly lines up with what Anurag Srivastava was researching regarding second-life batteries.
Yeah, his findings were super interesting.
He found that 2 identical batteries from the exact same year can have totally different fates. It's not the age that predicts the remaining value.
Right, it's the driving history.
Exactly. The depth of discharge, heat exposure, fast charging habits, that's what matters.
Akshay Kumar framed this so brilliantly. He said the industry treats residual value like this prediction problem at the end of a car's life.
Yeah, like you just roll the dice when you trade it in.
Right. But instead, companies should focus on preserving value from day one through intelligent operating policies. Residual value is built daily.
Oh, I love that. And speaking of building intelligent hardware, did you see Abukar Hassan's post about that project from Sweden?
The one about the DC charging hardware? Yeah, that was incredible.
For those who missed it, they figured out how to use the EV traction motor's own stator windings as a boost inductor.
Which is huge because it cuts out all those heavy, costly external components from the DC charging hardware entirely.
Yeah, total game changer for infrastructure costs.
Absolutely. And, passenger EV batteries are really proving their worth, but electrifying massive, heavy-duty logistics fleets is kind of the ultimate test.
Oh, for sure. The scale is just massive. And Sigrid Rodendahl mapped this out. She noted the EU needs 279,000 truck charging points by 2030.
And most of those aren't even on the highway, right?
Right. 84% of them will be at depots. The bottleneck is getting enough power into the fleet hub itself.
Yeah, and the global competition there is intense. Steph Cornelius pointed out that Scania's CEO actually lowered their 2030 e-truck projections from 50% to just 10%?
10%. Just blaming infrastructure.
Entirely blaming infrastructure. But the thing is, Chinese competitors aren't waiting.
Yeah, they are moving fast.
Senatrix sold 15,000 e-trucks early this year, compared to Scania's 133.
Man, 15,000 compared to 133. That's wild. But the technology is racing to catch up, at least.
It is. Ini Beheyufut shared that Alpatronic just upgraded a charger to deliver 1,000 kilowatts through a single liquid-cooled CCS connector.
1,000 kilowatts through one connector. That brings megawatt charging to current infrastructure without even needing new MCS plugs.
Yeah, it's a huge step. But if we connect this to the bigger picture, Anders Hove had a fascinating on-the-ground report from China about this.
Oh, about the charge and swap model.
Exactly. Heavy trucks are waiting at depots to charge during cheap nighttime electricity hours.
Okay.
But then they use fast battery swapping during the day to maximize operating uptime.
That is so smart, getting the best of both worlds. And Andy Way reported the CATL and Octopus Energy just formed a joint venture to bring this exact heavy truck battery swap network to Europe.
Yeah, it's moving incredibly fast, which kind of leaves us with a provocative thought to ponder.
Let's hear it.
Well, as bidirectional charging and battery swapping scale up, the line between vehicle and grid is really disappearing.
Yeah, for sure.
In the future, when your car is constantly trading energy with the city or, your truck swaps out its battery twice a day, who really owns the energy in your tank?
Wow. Yeah, that's a wild thought. You're just renting the energy at that point.
Uh-huh.
Well, if you enjoyed this episode, new episodes drop every 2 weeks. Also check out our other editions on future mobility and market evolution, next-gen vehicle intelligence, and commercial fleet insights. Thank you so much for joining us for this deep dive, everyone. Don't forget to subscribe, and we'll see you next time.